Generally speaking, to achieve automation of all processes, not only is the automation of individual tasks required, but the integration of each workflow is also essential. What we need for process integration is the process flow. The process flow is a feature to control the entire automated workflow, including various business events, such as regular events, email reception, and the completion of preceding processes. In other words, automation of tasks and processes refers to the implementation of automatic processes for each and every individual task that is carried out without human intervention, according to the established work procedures. During the application, the workflow must be controlled if interactions exist between the various unit tasks. To automate such a complex workflow, a process flow running on a server is utilized. Here is an example of a process flow implementation. The orchestrator server verifies the reception of emails that satisfy specific conditions according to the set time intervals. If such a mail has been received, or if the time interval is elapsed, the relevant work process, process A or B, will be executed. Then, when the execution of the process is complete, the process flow will be repeated until the email reception check process is repeated a total of 10 times. This indicates that an extended workflow can be implemented and executed as a process flow by combining a business event, such as the email reception, with unit task processes A and B. Process flows can be generated on the designer, but they can be executed only on a server. Therefore, process flows have a dedicated library for them and are managed separately from normal processes. Also, when generating a new project, new process flow must be selected as the project type to generate a process flow. On the designer screen, you can see that the recording and execution features are not available. Also, the generation of normal tasks or processes is not allowed, and only process flow management is available. Therefore, if normal processes are required for the project, you can search for them on a server and add them to the project. Besides, only the library dedicated to process flows may be used. As mentioned earlier, a process flow is generated on the designer, but it can only be executed on a server. Therefore, it is executed based on the server's time locale, which is the UTC. When it is executed, server-based services, such as the Process Flow Server and Event Manager, are launched on the server to run the process flow. Even though it can be composed of processes, the management, such as activating, executing, and monitoring of it, is separated perfectly from the management of normal processes. However, the methods for activating, executing, and monitoring the process flow are identical to those for normal processes. When generating a process flow on the designer, the Process Flow Management Area, Process Search Area, and the dedicated Library Area are displayed on the screen. The Process Flow Library is a group of activities required to generate process flows combined and provided in a package. Just as you would while generating normal projects, you can search the library and bookmark the activities. A process flow library is a collection of activities to control work processes according to the execution conditions which are used when fabricating a flowchart. For example, you can set a process flow to wait for certain user-defined conditions, such as reception of certain emails, a specific time, or the completion of a preceding task. When the set conditions are met, an event occurs as a result. Then, you can design the flow to allow the bots waiting for executions to proceed with the subsequent processes based on the events occurred. Essential activities include those for controlling process flow, configuring data, waiting for events, and executing processes. Let's first take a look at the activities for controlling process flows. The first element of a process flow control is judgment of conditions. If a diversion is required based on conditions, if or if then activity may be used. In the flowchart, the same basic operators are used to control the flow. Conditional operations are set to decide equal to, not equal to, greater than, smaller than, greater than or equal to, and smaller than or equal to conditions, and the diversions are made based on the true or false conditions returned as the result of an operation. Besides, conditional statements may include multiple logical operators, such as and or. If repeated executions are required, for each, and while activities may be used to execute a loop statement. In the for activity, set the initial value of the declared index variable I, condition for the loop, and the updated data. In the for each activity, a list type in an array format is set for the for list statement. Then, each of the list type items are assigned as variables of the each item statement. The for of and for in statements are used for the same purposes as they are in JavaScript. The while activity provides an activity for generating a loop that lasts until a specific condition is satisfied. The syntax for conditional operation is identical to that of the if operation we have reviewed earlier. Lastly, the delay, terminate flow, break, and continue activities are used when a flow need to be delayed or controlled otherwise. The delay activity is used to delay the process for the time set by the user. The delay time may be set in seconds or milliseconds. The terminate flow activity is used to forcibly terminate a flow that is currently running. It is identical to the return statement in JavaScript, and you need to enter the value that will be returned at the flow termination in the properties. The break activity is used to exit a loop generated by for and while activities at the time specified by the user. And the continue activity is used to enter the next loop cycle within the loop at the time specified by the user. Next, let's take a look at the activities related to data configuration. The add date time activity is used to store the entered data after adding the date and time data specified by the user. You can set the properties to specify the variable to store the changed processing result. Then, you can select the time unit and set the time value to be added as a number. The time unit may be set to years, months, days, weeks, hours, minutes, or seconds. Lastly, you can set the time data that will be used as the standard of the change to complete the setting. The assign and assign date time activities are used to assign a variable or to set time data. The assign activity is used to assign a value to a variable. In properties, you can enter the variable to assign a value and the value to assign. The assign date time activity is used to assign date and time data to a variable. In properties, you can set the time data to set and select whether to convert the time data into the UTC format and whether to utilize the locale information. The locale information can be utilized only when the UTC option is set to true. Then, the request asset activity may be used to request a shared asset registered on the server. For example, if common data, such as notification titles or common account text strings, are registered on the server as shared assets, the same values may be requested for use in multiple process flows. In the settings, select the variable to store the value of the requested asset object. Then, select the shared asset to request. Only the items registered on the server as shared assets are displayed on the list for selection. The execute script activity is used to implement the features required in the process flow utilizing user-defined JavaScript. You can compose the script using the JavaScript syntax. In the Properties settings, you can directly enter the script or double-click the Properties window to open and use a separate script window. Functions provided by the server which can be directly utilized within the execute script activity include the addDate function, which returns the time data after adding the requested time units to the standard time data. getNowStr function, which returns the current time as text string, and convertDate to str function, which returns a JavaScript date object in a text string. Let's continue to take a look at the activities related to waiting of events. First, the wait email activity is used to wait for an email containing information specified by the user to perform a specified action when it is received. By setting the properties, you can specify conditions, such as the sender, sentence to verify in the content, and the range of sent dates and time. Next, the wait HTTP activity is used to wait for an HTTP reception for the wait URL. The orchestrator server generates a unique wait URL, returns it to the variable specified in the wait URL field, and waits for the HTTP reception. Then, the reception result is returned to the variable specified in the variable field. The wake-up activity is used to perform a waiting until the specific time specified by the user. By setting the properties, you can specify the time to stop the waiting and resume the process. The wait for multiple events activity is used to wait until the event satisfying the set conditions is completed. The wait for multiple events activity must be used to perform a process after various preliminary processes are completed. In the settings, you can set whether to wait for all of the registered events and whether to stop if an error occurs, and then register the result variables for the waiting events. Lastly, let's take a look at the activities related to the execution of processes. The call process activity is used to remotely call a specific process and execute the process specified by the user. In the settings, you can specify the input value to be sent to the target process and the output value to be received from the process, and the process to execute among the server processes that were added to the process flow. Because the execution of a process is performed asynchronously, you need to set the result of the wait for multiple events activity as the event to ensure that waiting is maintained until the event is completed. Let's search for a process and add it on the designer. The process must be distributed to the server, activated, and authorized for use before you can execute it. Therefore, you need to search for the list of processes that are activated and authorized for use utilizing the process search on the designer. Then, you can select a searched process, right-click it, and run Add Process. You can see that the selected process has been added to the process flow. Next, the Call REST API activity is used to call REST APIs. The properties may be set in the same way as setting the standard HTTP protocol. Therefore, you can select either GET or POST for the call method, and one of text plain, application JSON, application XML, and multipart form data as the content type to receive the call. Also, you need to set the API call URL, certification information, and API header and body information to call a REST API. Among the activities related to the execution of processes, the Send Knox message activity is applicable for Samsung-affiliated companies only. The Send Knox message activity is used to send messages to Knox Messenger users and receive user selections provided via the messenger if required. By setting the properties, you can configure the type of user response to the message, such as No Wait, Wait OK, and Wait Yes, No, Cancel. Also, you can set the Knox ID of the user, enter the message content, wait time for the response, and specify the variable to receive the user response and process the result based on the user response. Then, utilizing the process flow library, let's generate a process flow which calls and executes a specific process at a specific time on a daily basis. First, let's summarize the flow of the process in a simple way. With assign date time, set the initial start time to after the current time. Set the wake-up activity to call the process at 9 o'clock every day. Wait for the result of the wake-up activity using the Wait for Multiple Events activity. At 9 o'clock, the call process activity runs the specified process, and the Wait for Multiple Events activity waits until the process is completed. Then, the Add Date Time activity changes the execution time to the same time on the next day. The while statement generates a loop, and the wake-up activity waits until the set time. Now, let's generate a process flow. Before proceeding, remember that the routine process must first be generated, distributed to the server, and activated in advance. Use the Process Search feature to search for the advanced unit process previously registered to the server and add it to the process flow. Then, in the process list of the process flow named Advanced Process Flow Test, which we are currently generating, you can see that the advanced unit process has been added. Now that the process has been added, let's set the process to be called at 9 o'clock every day. First, use the Assign Date Time activity to set the start time for the process flow and store the result in the S-time variable. Next, use the wake-up activity to set the S-time to trigger an event and store the result in the wake-up result variable. Then, register the wake-up result event in the Wait for Multiple Events activity and allow it to wait until the condition is met. Next, in the Call Process activity, set the advanced unit process that was previously searched from the server and registered, and store the result in the Call Result variable. To make the flow wait until the executed process is completed, add another Wait for Multiple Events and set the Call Result variable as the wait event. Lastly, to set the next execution time, use the Add Date Time activity to update the current S-time variable after adding 1 day to it. After generating the process flow this way, in the Export menu, run the Publish to Server feature to distribute it to the server. Then, the process flow distributed to the server is activated and executed via the user portal. The progress of the currently executed process flow can be monitored via the monitoring screen of the user portal. Now, let's apply the content we have learned so far to a scenario for making an inquiry for the exchange rate and sending a reply when an email requesting an exchange rate is received. Let's first assume the work process scenarios. Receiving random inquiries about exchange rates is preventing Accountant A from effectively carrying out the daily tasks by causing serious interruptions because the exchange rate must be manually searched for and the request emails have to be replied to each time. To improve the work process, we are going to generate processes for inquiring the exchange rate and replying to email inquiries about exchange rates, and generate and execute a process flow to automatically run these processes when an email requesting an exchange rate is received. Let's take a look at the improved work procedure utilizing Brity RPA. First, the process flow waits for an email requesting an exchange rate utilizing the while and wait email activities. When an email request for an exchange rate is received, the result of the mail reception is returned to the Wait for Multiple Events activity. The call process, triggered by the email reception, executes the exchange rate inquiry process first and waits for the result of the exchange rate inquiry by utilizing the Wait for Multiple Events activity. Then, the call process, triggered by the exchange rate inquiry, result executes the reply process. Lastly, the wait email activity waits for the next email. To implement the process flow we reviewed earlier, unit task processes, which are the exchange rate inquiry process, and the reply process must be generated, distributed to the orchestrator server, and activated in advance. In this exercise, we generated the Advanced Process Project, the Exchange Rate Unit Process, and the Mailing Unit Process in advance. The exchange rate unit process receives the email subject and extracts the country name via the REQ-SUBJ variable to make the exchange rate inquiry, and returns the country name, exchange rate, and currency information via the nation name, EX rate, and EX type variables, respectively. The mailing unit process receives the recipient's email address and the reply content via the mail ADDR and EX rate STR input variables to send a reply to the request for the exchange rate. Then, the advanced process project we have generated is distributed to the server via the Publish to Server feature under the Export menu. After the distribution to the server, the project is activated on the Process Management screen of the user portal. First, in the Project tab, select the Advanced process. Then, click the Activation button to configure the Automation Bot group and Automation Bot to execute the Exchange Rate Unit process and the Mailing Unit process. After the activation process, the Exchange Rate Unit process and the Mailing Unit process will be activated as shown in the example. From now on, let's take a look at the procedures for generating a process flow, distributing it to the server, and executing it on the actual designer screen. On the designer, generate a new process flow named Advanced Process Flow. Then, search the server for the unit task processes that will be used in Advanced Process Flow and register them. For this example, the previously mentioned unit task processes, exchange rate unit process, and mailing unit process have been registered to the server and activated in advance. Therefore, they will be searched as the activated processes on the server when you enter the keyword unit in the process search field of the designer. Select Exchange Rate Unit Process, right-click it, and then click Add Process. Also, register the Mailing Unit process in the same way. Then, you will see that the Exchange Rate Unit process and the Mailing Unit process have been registered under the Advanced Process Flow, which means that these two processes will be available within the Advanced Process Flow. From this point on, we will continue to implement the process flow step by step by utilizing the Process Flow library. According to the improved work procedure we planned earlier, we will create the overall structure for the process flow by placing relevant activities. Place the while loop statement and place the wait email statement within the loop. Then, place the Wait for Multiple Events activity to wait for the email reception event for an exchange rate request. After that, place the Call Process activity for the exchange rate inquiry and add the Wait for Multiple Events activity to wait for the result of the inquiry. Then, place another Call Process activity and add another Wait for Multiple Events activity to execute the process for sending a reply with the exchanged rate obtained from the inquiry. This way, the essential activity structure has been created for the improved work procedure we have planned. From now, let's set the detailed conditions for the process flow and the variables that will be used by the activities. First, let's proceed with the step to wait for the reception of an email for an exchange rate request. To ensure that the process flow can be executed without being terminated, set the condition for the while statement to true to allow a constant value. Next, in the Wait Email properties, set the detailed conditions for the email request that will be received. The server address for email reception, the reception account, and password are required. We are using an Input tab to enter the password to prevent it from being exposed. You can select an option appropriate for your work environment for this setting. So, let's proceed with setting the selection conditions for the received email for the process flow. Initialize the receiver and end time values to remove the limitations, and set the subject to Request for Exchange Rate. Then, define the BTime variable by setting the begin time, which is the starting condition for waiting for an email, to the BTime variable. Now, add an execute script. As we have learned earlier, utilize the getNowStr function to assign the start time to the BTime variable. Lastly, define the mail result variable to store the result of the wait email activity and set it as the value of the result item in the properties. Next, let's proceed with the step for returning the result of receiving the email requesting for exchange rate. First, define the event result variable to store the returned result of the wait for multiple events activity. Then, among the wait for multiple events properties, assign the wait for item to the mail result variable to store the wait email result, and set the event result variable to store the returned result of the event. Proceed with setting the call process activity to execute the unit task process for an exchange rate inquiry when an email is received. First, of the two work processes registered in the process flow, select the exchange rate unit process for an exchange rate inquiry as the process item of the call process activity. When you do this, the call process input and output properties that match the variable structure of the previously implemented exchange rate unit process are displayed on the designer screen. This means that the input and output variables of the exchange rate unit process, REQ, SUBJ, nation name, EX rate, and EX type, are displayed as the call process input and output properties. Now, set the input and output properties of the call process activity to accurately execute the exchange rate unit process when it is called. First, set the input item to receive the email title value within the mail result variable, which contains the result returned by the wait email activity. Then, define the call result variable to store the result of the call process activity, and assign the result item of the call process activity to call result. The rest of the call result output properties will be automatically populated with the output variables of the exchange rate unit process that are returned by the call result variable. Then, set the wait for multiple events activity to wait for the result of the call process activity as the event. For this, select the call result variable for the wait for item in the properties and set the event result variable to store the returned result of the wait for multiple events activity. Then, set the email address required to send reply and create the content of the reply by utilizing the result of the exchange rate unit process that is returned via the call result variable. First, define the mail ADDR variable to store the email address and the EX rate STR variable to store the content of the reply. Then, add an execute script to read the reply address from the mail result variable and store it to the mail ADDR variable. After that, create a script to read the country name to get the target country name, exchange rate, and currency from the call result variable. Compose the reply content and store it in the EX rate STR variable. Now, let's set the call process activity to send a reply to the request for an exchange rate. First, select the mailing unit process as the process item of the call process activity. When you do this, the input variables of the previously implemented mailing unit process, Mail ADDR and EXRate STR will be displayed as the input property items of the call process activity. Assign each of the input properties to Mail ADDR and EXRate STR variables processed earlier by the execute script. Then, assign the result item of the call process activity to the call result variable to store the result of the call process activity. Then, select the call result variable for the wait for item of the wait for multiple events properties and set the event result variable to store the returned result of the wait for multiple events activity. The last step is one for waiting for the reception of a request email. Add an execute script and initialize the btime variable value to set the wait email activity to wait for an email within the while loop statement. The generation of the process flow has been completed. Now, let's distribute the advanced process flow to the server by selecting the Publish to Server feature under the Export item of the designer's main menu. Then, let's proceed with activating and executing the process flow on the user portal. Log into the user portal, click the Process menu, and select the advanced process flow we have previously distributed from the list. On the advanced process flow screen, you can see that the exchange rate unit process and the mailing unit process have been registered. Click the Activation button on the right to activate the process flow. To execute the process flow on the server, access the Monitoring menu to open the Job Execution History screen. Click the New Job button to open the Execute Job window. Select the Advanced Process Flow and click Next. On the progress status of the Execute Job window, view the Bot group and bot settings for the unit task process and execute the process flow. You can monitor the executed process flow by accessing the Monitoring menu in the Process Flow History window. You can click the View button under History to view the detailed execution history of the process flow. On the screen, you can see that the process flow has been executed for the first time, and the Wait for Multiple Events activity is waiting for an event to occur. Now, by sending an email requesting an exchange rate to the designated recipient, let's review the steps through which the email reception event is processed with the process flow. The exchange rate is inquired, and the reply is sent. As you can see on the screen, an email titled Algeria, Request for Exchange Rate has been sent. A reply containing the exchange rate for Algerian dinar has been received, and each step of the process flow execution on the server can be viewed on the user portal.